hydraulic press plate system. It is a system that transforms vehicle kinetic energy into clean electricity using Pascal's principle. By harnessing the force of cars driving over hydraulic plates, this innovation turns roads into renewable energy sources, reducing reliances on fossil fuels and promoting sustainability.
Now, let us talk about the structure of the hydraulic press plate. The system is made up of two parts. One is the traditional speed bump on the top surface, while the other part is the hydraulic system built beneath the speed bump. The system can be also segregated into two sections, each section with one speed bump and a hydraulic generator. The traditional speed bump is made up of reinforced rubber and fiber reinforced polymer, FRP, to provide the speed bump with the characteristics of durable and weather resistant. The hydraulic system consists of hydraulic cylinders, hydraulic fluid, and hydraulic generator. The hydraulic cylinders are made up of high-strength stainless steel to ensure it is corrosion resistant. The hydraulic fluid used is biodegradable hydraulic fluids like vegetable-based fluids to prevent environmental harm. The hydraulic generators helps to convert pressure into electricity using a hydraulic motor and alternator.
For our demo, we used a combination of vertical handheld air pump, which is the neon part of the structure, and PVC cylinders as the hydraulic cylinders. Water is used as hydraulic fluids, while a simple hydraulic motor is used to generate electricity. Waterproof tape is used to prevent leakage of hydraulic fluids and to maintain the difference in hydraulic pressure within the system.
Initially, one press plate is slightly higher, which is above the road, while the other press plate is slightly lower, which is the same height as the road. When cars drive over the first press plate acts like a vertical handheld air pump, and the press plate then moves downwards. This produces a strong force for the hydraulic system underneath, where the system is able to absorb this force and transfer the pressure into hydraulic fluid movement. The hydraulic fluid moves down the hydraulic cylinder and passes through the hydraulic generator. The hydraulic motor spins a generator, converting kinetic energy into electricity. The hydraulic fluid passes through the hydraulic motor and moves towards the second press plate. The strong hydraulic pressure causes the second press plate to rise. The first press plate is now lower, while the second press plate is now higher. The car then passes through the second press plate. The mechanism is then repeated, with the weight of the car producing a strong force for the hydraulic system underneath, where the system is able to absorb this force and transfer the pressure into hydraulic fluid movement. The hydraulic fluid then passes through the respective hydraulic motor of the second press plate to generate electricity. The hydraulic fluid then moves back to the first press plate. The first press plate is now higher while the second one is lower.
Overall, the fundamental of our system is Pascal's law of hydraulics, which states that when pressure is applied to any part of a confined incompressible fluid, the pressure change is transmitted equally in all directions throughout the fluid, meaning that the pressure increase at any point in the fluid is the same as the pressure increase at every other point within the container.
The hydraulic press plates that we thought of has the below benefits. Energy harvesting for sustainability. It promotes renewable energy, as the hydraulic press plates can convert kinetic energy of vehicles into usable electricity. The electricity generated can be used to power street lights, charge traffic signals and signs, support roadside EV charging station, and even feed excess energy to contribute to a smart city infrastructure. Thus, it can help reduce carbon footprint and maximizes road efficiency. Secondly, improve traffic safety. Speed bumps in general are able to slow down vehicles on the road, which encourages drivers to slow down in designated areas like school zones, pedestrian crossings, and residential areas. Thus, This helps to enhance road safety without causing unnecessary discomfort for responsible drivers. Next, cost-effective in the long run. These hydraulic press speed bump systems helps reduce electricity costs of the cities, has relatively low maintenance needs, and thus is able to save money for governments and cities. Lastly, it has high scalability and versatility. When a system is maturely developed, it can be applied in toll booths, highway axes, parking lots, industrial zones, and bridges and tunnels. Thus, it is said to be a scalable solution that fits various locations and traffic conditions. All in all, the hydraulic press plate is not only a traffic solution but also a sustainable energy innovation.
Our hydraulic press plates align with the United Nations 17 Sustainable Development Goals (SDGs) in several ways. The first one is SDG 7, Affordable and Clean Energy. The hydraulic press plates provide a renewable energy source by converting car motion into electricity and helps to reduce dependence on fossil fuels and promotes clean energy solutions. Number 2 is SDG 9, Industry, Innovation and Infrastructure. Encourage innovative infrastructure development by integrating energy production into road. Promote sustainable industrial solutions and advanced energy technology. Number 3 is SDG 11, Sustainable Cities and Communities. Contribute to energy-efficient urban infrastructure. Supports eco-friendly cities by harnessing energy from traffic in busy urban areas.
To conclude our invention, the hydraulic press plate system demonstrates a sustainable and innovative way to generate electricity from vehicle movement using Pascal's principle. By converting kinetic energy into clean power, this technology offers a scalable solution for reducing reliance on non-renewable resources. With further optimization, it has the potential to transform roads into energy-generating networks, contributing to a greener future.